With this investigation, I wanted to see if a bald spot was left behind on the charged pipe after it was used to charge the electroscope by contact. I have attached the thin brass rod to the stem in order to increase the distance between the charged pipe and the small ball at the front of the electroscope. I'm going to charge the electroscope from this particular spot on the pipe. Charging the pipe negatively. Charging the electroscope. The deflection is about 50 millimeters after removing the pipe. Discharging the electroscope. Touching the electroscope at the same spot on the pipe than before. The ball deflects and swings back up after being earthed, but collapses after the pipe is removed. The fact that the ball did not swing back up after the pipe was removed tells us that virtually no bound electrons were transferred from the pipe to the electroscope. You could actually see it bounce naturally onto the stem at the end of the clip, which is a strong indication that the system is not charged at all. Let's look at it again. Discharging the electroscope, touching the bald spot on the pipe to the electroscope, earthing the ball, removing the pipe. This means that a bald spot was created at the point on the pipe where it was touched to the electroscope the first time around, and that no charge was transferred to the electroscope the second time round. The reason why it deflected at all can be explained by induction. The pipe pushed some of the conduction electrons off the stem onto the ball, after which the negative charge on the rest of the pipe repels it. Let's look at it again. This is the first time around when the pipe was still fully charged. Charging the electroscope negatively by contact. Charging the ball to the max. Watch how the ball falls back down when the charged pipe is removed. This tells us that the pipe is repelling the ball through the acrylic sheet. How do the charged pipe succeed in repelling the charged ball through the electrical insulating sheet? This plexiglass sheet is the same material I used to mount the copper stem of the electroscope on. Here you can see that this sheet is not charged, otherwise it would have attracted the little ball. Charging the PVC pipe negatively. Charging the little ball negatively. Mounting the pipe in a clamp. Inserting this sheet in between the charged pipe and the charged ball. Surprisingly, the deflection of the ball increases. It drops back down when the sheet is removed. Removing the charged pipe. Discharging the ball. The sheet is still not carrying any charge. Why did the deflection of the ball then increase when the sheet was inserted between the two charged objects? Here, two different materials are brought into contact with each other. One material has a greater affinity for electrons and removes some from the other. A charge imbalance is created and they become electrically charged. We find a similar situation in molecules where electrons are shared unevenly among the various atoms, leading to one side of the molecule becoming slightly negative and the other side slightly positively charged. They are then called polar molecules. In a dielectric or insulating material, we find that the polar molecules are randomly orientated, but become aligned when a charged object is brought nearby. Note the appearance of positive charge on the left-hand surface and negative charge on the right-hand surface of the insulator. This explains how the charged pipe succeeded in repelling the charged little ball through the plexiglass sheet. The influence of the charged pipe or the electric field generated by it is not stopped by the insulating material. This is also evident from the fact that cell phone reception is possible inside buildings or vehicles. This is proof that the electromagnetic waves can propagate through the walls or sides of the structures. This close-up shows that the insertion of the plexiglass sheet actually improved the transmission of the electric field generated by the charged pipe. Here I use the pipe to charge the electroscope from another spot on the pipe other than the bulb spot. This was done without recharging the pipe with the cloth. In this case the deflection is about 6 centimeters. What can we learn from this? Previously the deflection was about 5 centimeters. I think the difference in the deflection is significant. This means that the distribution of the electric charge over the surface of the pipe is uneven. In some places the concentration of charge is higher than in others.